Hey, 7th grade. So in the last couple of videos we learned how to simplify expressions. And so we learned about combining like terms and the distributive property, and we used both of those in order to take a long expression and squeeze it down. So you might have had something like 2x minus 4x, and we would have said that since those are like terms, you can combine those to negative 2x. But at that point we stopped. A lot of times I get students who confuse what we did in the first two videos, which was simplifying expressions, with what we are going to do in these next several videos, which is solving equations. And there's a big difference between expressions and equations. An expression is just going to be a strand of numbers, variables, operation signs, but it's missing one thing that equations have, and that would be an equal sign. So when you worked with expressions, there was no equal sign. And now that we're going to get into equations, you're going to see basically two expressions that equal to each other. You might see something like negative 2x equals positive 4. And so when you have equations, you can actually go a step further and you can solve for a variable and tell me what x is actually equal to. And so that's what we're going to talk about in these next several videos. So in order to solve, or sometimes we say find the solution of an equation, the solution just means find the answer, we use what are called inverse operations. And what inverse operations do is they undo the operations within an equation. Every single time we try to solve an equation, whether it be a basic one-step equation like we'll do today, or a quadratic equation like we'll do at the end of the year, our goal is the same. Our goal when solving all equations is to isolate the variable. And by isolate, I mean get the variable by itself. And so in order to do that, you have to know what your inverse operations are. Inverse is another way of saying opposite. So the inverse of addition, we know, hopefully, is subtraction. And thus the inverse of subtraction is addition. The inverse of multiplication is division. And that means the inverse of division is also multiplication. So you need to know what your inverse operations are in order to solve an equation, and you also need to remember this, that equations are like balances. If you've ever used a balance in science class, okay, you know a balance with a pan on this side and a pan on this side. In order to keep that balance each side level with each other, you know that anything you add to one side, you have to add the exact same thing to the other. Anything you take away from one side, you have to take away from the other. And so the same thing is true when you have an equation. Whatever you do to one side of the equation, you must do that to the other side. And so we're going to look at several examples here. These are just going to be basic one-step equations. You may have seen these back in 6th grade when you took math class then as well. And I do want to see you showing work on your notes for these and also your homework. I don't want to see just answers when you're going through these problems. Even if you think you already know how to do it, I want to see a step in between your work, in between the question and your answer for each of these. So let me show you what I mean. If we look at number 1, we have x plus 13 equals 27. And we want to find what number x would have to be so that when you add 13 to it, you get 27. Well, we're going to do that using our inverse operations. So my goal is to get x by itself. If I have an x plus 13, that means I need to do the opposite of adding 13. So I need to subtract 13 from this left side. Well, whenever I subtract 13 from positive 13 minus 13 is going to give me 0. So really, 13 and negative 13 cancel each other out, because when we put those together we get 0, and we're left with x on this left side. But if you remember what we said up here, equations are like balances, so whatever you do to one side of your equal sign, you have to do on the other side as well. So now we're going to go to the right side of my equal sign, and I have to subtract 13, just like I did here on the left side, on the right side. 27 minus 13 is 14, and so this gives us x equals positive 14. When you're doing your work on these, I think it's best to try to line up your equal signs and keep those in a nice straight line down the work, and that helps you out as you're going back through work if you made a mistake. it helps you keep a little bit more organized work. So I'm going to be looking for that. Are your equal signs lined up as you're working through these problems? Okay, for number 2, we have negative 18 equals 6 plus w. And so this time our w is on the right side. We want to isolate this variable here, and so I'm going to look at what's attached to the w. I'm adding a 6 to the w, and so the inverse of addition is again subtraction. To get rid of this 6, I need to subtract 6 from the right side. And positive 6 minus 6 is going to give me 0, so those are going to cancel each other out. That means I also need to subtract 6 from the left side because I need to keep my equation balanced. And so negative 18 minus 6 on this side is going to give me a negative 24. Line up your equal signs, and then all that's left on this side is w. So this tells me that w equals negative 24, and that makes sense because 6 plus a negative 24 would have given me a negative 18. Okay, for 3 and 4, this time I've got some subtraction for number 3. m minus 10 equals positive 2. The opposite of subtraction is addition, so I need to add 10 to the left side in order to get rid of this minus 10. Negative 10 plus 10 is going to give me 0, so those will cancel each other out. And because I added 10 on the left side, I need to add 10 on the right side. So this gives me just m on the left side. Bring down my equal sign, equals 2 plus 10, which is 12. So we know m equals 12. Number 4, we have negative 7 equals negative 3 plus b. Well, our goal is to isolate the b, and even though we see addition in this problem, I want you to pay attention to the sign in front of the 3. The sign in front of the 3 is a negative sign, and so we're going to treat this like a negative 3. To get rid of a negative 3, we need to add 3, and that's going to give us a 0 when we take negative 3 plus 3. So even though you see addition for this problem, we're still going to use addition to get rid of our 3 because the 3 itself was a negative. So negative 3 plus 3, that's going to give me 0, and then I also need to add 3 on the other side of my equal sign. Negative 7 plus 3 gives you negative 4, and that's going to be equal to my b value. Okay, for number 5, I'm changing my operation again. This is 3a, or 3 times a, equals 12. Anytime you see a number written directly next to a variable and there's no sign in between, it means multiplication. So the opposite of multiplication is division. To get rid of this 3 here, I need to do the opposite of multiplication, so I need to divide this side by 3. That means I also have to divide my right side by 3. So when I take 3 divided by 3, that just gives me a 1. And so what I can do is I can just say these two cancel each other out. 3 divided by 3 is 1, so I'm going to get a 1a, or just a, on the left side. And that's going to be equal to 12 divided by 3, which is 4. For number 6, my variable's on the right side, so I need to get rid of this 5. It's 5 times y, so we're going to use division to get rid of the 5 by dividing both sides by 5. So over on the right side, 5 divided by 5 is 1, so we'll get a 1y, or just y, on this side. And on the left side, you can write your answer in 2 ways. I don't care if you leave your answer as an improper fraction. As long as it's reduced, that's fine. So this would be the fraction negative 8 over 5, or negative 8/5. And I am perfectly fine with that answer right there. The other answer you could give me is if you take 8 divided by 5 and just type that in to a basic calculator, you're going to get a decimal of negative 1.6. So you can also tell me that y equals negative 1.6. Decimal answers are okay in this class as long as they're not repeating decimals or rounded decimals. So if this were something like negative 1.6 repeating, then I would not want that as an answer. But since it's a normal decimal, it stops at 0.6, that's fine too. So either one of these is perfectly fine for your answer. Okay, for number 7, we have negative a over 5 equals negative 20. Whenever you see a negative sign in front of a fraction, you can think of it being written in two ways. That would mean the same thing as negative a divided by positive 5 or a divided by negative 5. So you can take that negative sign and you can put it either in the numerator or in the denominator, just not in both. So I'm going to take that negative sign and I'm going to put it with my denominator here, and I'm going to rewrite my equation as a divided by negative 5 equals negative 20. And the reason I'm doing that is because now I know, since I'm dividing a by negative 5, I need to use the opposite of division. I need to use multiplication to get rid of this negative 5 to isolate my a value. So I'm going to multiply both sides by negative 5. Well, when I multiply a over negative 5 by negative 5, I'm really multiplying by negative 5 over 1. So that negative 5 and that negative 5 will cancel. And so I'm left with a over 1, or just a, which will be equal to negative 20 times negative 5. A negative times a negative is a positive, so that would be equal to positive 100. Okay, for number 8, we have 4/5 m equals 28. So for this one, it's 4/5 times m. Again, to get rid of multiplication, we divide. So we're going to divide both sides by 4/5. Now, if you look at this and you think this is written kind of weird, you'd be right. We usually don't write a fraction inside a fraction. We have 4/5 over 4/5, and that looks a little bit strange. So what I want you to remember is I want you to remember the rule for dividing by fractions. Dividing by 4/5 would be the same thing as multiplying by its reciprocal. It'd be the same thing as multiplying by 5/4. So instead of writing it this way, I'm actually going to change that to multiply both sides by 5 over 4. It's going to give me the exact same thing, but it's going to look a little bit nicer. When I write it this way, you can see that 5/4 times 4/5, your 5's will cancel and your 4's will cancel over here. So you're just left with your m equals, over here, 28 over 1 times 5 over 4. We can cancel our 4 and our 28 to a 1 and 7, and that just gives us 35 over 1, or just 35. So we know m equals 35. Okay, you do have one more example on the back side, but that's actually something we're going to discuss during class. And so when we come to class to discuss these notes, we're going to do that last example on the back side together. And so this is all the notes you have to take for today. Make sure you write down at least one question about something we talked about in these notes here, and I will see you in class the next time. Have a nice day. You're all wonderful people.